Hi everyone. Question 1 asks or states selected values of a differentiable function f are given in the table above. What is the fewest possible number of values c in the interval 1 to 9 for which the mean value theorem guarantees that f prime of c is 6? Now, a couple things that are important to note. The first thing is that we need to see, well, can we even use the mean value theorem? And I know the answer is yes, because this function is differentiable. Since the function is differentiable, it also means that it's continuous. And since both of those are true, we can use the mean value theorem. To remind us, what is the mean value theorem? The mean value theorem states that on the interval from a to b, there will exist some point c, so c is going to be somewhere in the middle, such that the derivative at c is equal to the average rate of change between a and b. So that's what this is saying. And I'm restating it in math terms here, but just again, there is some point where the derivative is the same as the average rate of change, where the instantaneous rate of change is the average rate of change. And so they're asking where is that equal to 6? Now, the thing about this question is that it's a little difficult only because you have to do a lot of the same things over and over and over again. What I mean by that is you need to check every single possible interval here. The first intervals I see are between these points, and I'm going to draw these in red. Between 1 and 3, 3 and 5, 5 and 7, 7 and 9. Then the next intervals I see, I'm going to do these in blue, between 1 and 5, 3 and 7, 5 and 9. And then I see an interval, I'm going to do this in green, between 1 and 7, 3 and 9. And the final one, I'm going to do this in yellow, is between 1 and 9. Look, a little pretty rainbow. And so we need to test all of these. And you might be like, oh, that's so many. It gets faster because you'll realize exactly what you're doing. Our goal is that we need to find the average rate of change on those intervals. And we need to see if it's equal to 6. So, does AROC equal 6 is our question. And so we're going to start with those smaller intervals, and I'm going to write them here, 1 to 3. And so to do that, we got to do f of 3 minus f of 1 over 3 minus 1. And we're going to replace those values. F of 3 I see is 6. F of 1 is 0 over 3 minus 1, which would be 6 over 2, which is 3. That's not 6, so that doesn't count. Nope. Now let's test the next interval, 3 to 5. 3 to 5. And I'm not going to write out the function notation anymore. You know that it's f of 5 minus f of 3. So I know it's going to be 18 minus 6 over 5 minus 3, which is equal to 12 over 2, which equals 6. This one works. Okay, great. Now the next one, 5 to 7. And here's the thing. I'm writing out all this work, but you don't have to. You can just quickly go like, check the interval, check the interval, check the interval. I'm just here to show you what the work actually does look like. The next one is 29 minus 18 over 7 minus 5. That's going to be 11 over 2, which I know is not equal to 6. It's equal to 5.5. So that one doesn't work. And then 7 to 9. Testing that one, 7 to 9, 42 minus 29 over 9 minus 7. 42 minus 29, that would be 22 minus 9, that's 20 minus 7, which is 13 over 2, which is 6.5, and that one doesn't count. All right, so I've done all the red intervals. Now we need to check the blue we need to check the blue intervals. Because it can be true on a bigger interval, so we need to check those too. So let's test those out. I'm going to now start writing the blue ones. The first one is 1 to 5, which would give us 18 minus 0 over 5 minus 1, which is 18 divided by 4, which is 9 divided by 2, which is 4.5. That one does not work. The next one we're going to test is from 5 to 7. Not 5 to 7, sorry. From 3 to 7. So that's going to be 29 minus 6 over 7 minus 3, which is 23 over 4. I know that's not going to equal 6. I think it's 5.75. It does not equal 6 is all I'm going to write. So that one doesn't work. Now let's check the next one, which is going to be, the next blue I see is 5 to 9. 5 to 9. So that's 42 minus 18 over 9 minus 5 over 4. 42 minus 18 is 24. So 24 over 4 is 6. This one works. And so now I see two intervals that have worked so far. Now let's check the green ones. The green intervals, I see that's 1 to 7, which would give me 29 minus 0 over 7 minus 1, which is 29 over 6. That's not equal to 6. And then the next one is 3 to 9. 3 to 9 is 42 minus 6 over 9 minus 3, which is 40 minus 4 is 36 over 6 equals 6. Okay, that one works too. And then the last one that we need to test is this yellow one, which is the whole from 1 to 9. We test from 1 to 9, 42 minus 0 over 9 minus 1, 42 over 8. That's not going to equal 6, so that one doesn't count either. Oh, and I should put an X next to that green one that doesn't count. Okay, so first, we're going to look at where are the places that we saw that the mean value theorem actually gave us a solution. I see that happen here from 3 to 5. I see that happen here from 5 to 9. And I see that happen here from 3 to 9. So you might think, okay, the answer is 3. I found it 3 times. The answer is going to be 3. And here's what I'm going to tell you. That's not completely true. Because the interval from 3 to 9, that interval from 3, I'm going to write 2, 9, contains the intervals 3 to 5 and 5 to 9. That's inside there. So whichever value in this one and this one gave us that derivative of 6, it could already be in the third interval that we found. So that's not like a separate possible value. It could be extra, but we don't know if that's true. So the question's asking for the fewest possible number. The fewest possible is that it's 2, one from here and the other from here. And that other one could just be one of those other two. And so our final answer here is 2. There are 2 possible values for C that would guarantee that f prime of C equals 6.